Welcome to the 12th session for the 12th problem solving session for the course Introduction to Probability Theory and Statistics. And today we are going to discuss the questions on correlation and regression. So the first question is, if the correlation coefficient of two random variables x and y is 0.8 and regression coefficient of x on y is 0.32, then what is the value of regression coefficient of y on x? Okay, so um, this correlation coefficient of x and y is given 0.8. The regression coefficient of x on y is given 0.32. This means that x is dependent and y is independent. We need to find regression coefficient of y on x, where y is dependent and x is independent. So we know the formula, which is Rxy is equal to, there is a relation, is equal to Bxy into sigma x by sigma y. Similarly, Rxy is equal to Byx into sigma y by sigma x. So we know this values, we know this value, and we need to find this value. Okay, so this is equation 1, this is equation 2. So from equation 1 we get 0.8 is equal to 0.32 into sigma x by sigma y. So sigma x by sigma y is equal to 0.8 by 0.32. Now putting this value in equation 2, we will get 0.8 equal to Byx into sigma y by sigma x. So this will be 0.32 divided by 0.8, because this is sigma x by sigma y. Here we want sigma y by sigma x. From here we will find that this Byx is 0.8 into 0.8 divided by 0.32, which is nothing but equals to 2. So the regression coefficient of y on x is equal to 2. Moving to the next question. Given this data, we need to find the correlation coefficient between the following data. So we're given some values of x and y. We need to find the correlation coefficient between these two. So from here we can find this average for x, which will be 3 plus 5 plus 1 plus 7 plus 5 divided by 5. This will be 4.2. Similarly, we will calculate y bar, which will be 3.4. Okay, now this we need to, this correlation coefficient denoted by this is equal to sigma xi minus x bar yi minus y bar divided by sx into sy. Okay, where sx is xi minus x bar whole square divided by n minus 1 root. Sy is yi minus y bar divided by n minus 1. Basically the variance. Standard deviation of x and standard deviation of y. Okay. So we will make a table x, y. This will be minus 1 by 2. Xi minus x bar. X bar is equal to 4.2. And y bar is 3.4. So 3 minus 4.2 minus 1 by 2. 5 minus 4.2 is 0.8. 1 minus 4.2 minus 3.2. 7 minus 4.2 is 2.8. And this will be 0.8. These are separate columns. Then 4 minus 3.4, 0.6. 3 minus 3.4 minus 0.5. And similarly you find this. Now you will multiply these values together. Okay. For the numerator, we want this summation of the products of these two values. So this is minus 7.72 minus 0.32. So these are the values. So the summation of xi minus x bar into yi minus y bar from I1 equal to 5 is equal to summation of all these values, which is 22.6. Okay. Now we will find this Sx, which is standard deviation of x. So this is xi minus x bar whole square and minus 1. So this will come out to be 1.49. And similarly S5 will come out to be 2.67. Now this correlation coefficient will be this x bar yi minus y bar divided by s x into si. So this value came out to be 22.6. This was 1.49 into 2.67. This will come out to be around 5.69. This is the correlation coefficient for x and y. Okay. So we were asked the correlation coefficient between x and y. So first we calculated the average, which is 4.2 and 3.4. Then we took the difference of each element with the average, okay, for both the variables. Then we multiplied these together, and then we found the standard deviation for variable x and standard deviation for y, and put the values in this formula, and we get this value. Moving to the next question. Now we need to find the regression coefficient and obtain the line of regression for the following data. So as we did earlier, we make a table. It will be easier. So it is not mentioned like which of the variable is independent and which of the variable is dependent. So we will calculate for both the cases when x is dependent and when y is dependent. So, so we will just first we will calculate these values. So this x is y, that is corresponding y values are these. And this is the multiplication of x and y. Okay. So this summation of x will be 28. Summation y is 77. Summation x square is 140. Summation y square is 875. And summation xy is 334. Now this x bar will be 4 and y bar will be 11 because there are total n is equal to 7. So first let x is dependent. Okay, so we will find regression coefficient of x on y. So this will be n sigma xy minus sigma x into sigma y divided by n y square minus sigma y whole square. Okay, so this is summation y square. So we know this sigma xy value, this is 334. We know this sigma x is 28, sigma y is 77. We will put these values. N is 7. Sigma xy is 334 minus 28 into 77 divided by this value comes out to be 0.929. Now This x minus x bar is equal to bxy y minus y bar. So on putting this x bar and y bar value, we will get a equation for a regression line. So this will be x equal to 0.929 y minus 6.219. This is the regression line when x is dependent variable. So this is I put this value of x bar and y bar and bxy. X bar is 4, y bar is in. This is bxy, this is 0.929. This is y bar is 11. So I will just write it again. X minus 4.929 y minus 11. X minus 4.929 y minus, this will be some value. So this is 0.929 y minus 0.929 into 11 plus 4. Y. This value comes out to be 6.21. Okay. Okay. So now let y is dependent variable. Now we will need to find this byx, which will be n sigma xy minus sigma x into sigma y. But now in the denominator we will get sigma x square minus sigma x whole square. So we know these values. I'm putting these values. Okay, in the previous I had read 28, it is 77. It was sigma y square. It was 77. Here it is sigma x square, which is 28 square. This will come out to be similar 0.929 again. Now we will find the regression line. Y minus y bar is equal to 0.929 x minus x bar. So this y minus 11 equal to 0.929 x minus 4. So this will come out to be y equal to 0.929x plus 7.284. This is when y is dependent. Okay. So I hope this is clear. Moving to the next question. So we need find the means of x and y variable and the coefficient of correlation between them from the following two regression equations. So we are given two regression line equations and we need to find the mean of both variables and the correlation coefficient between them. So we are given two equations, 2y minus x minus 50 equal to 0. Another is 3y minus 2x minus 10 equal to 0. Let's suppose this is equation 1 and let's suppose this is equation 2. So let equation 1 is regression line to see dependence of y on x. Okay, this is representing the dependence of y and we are supposing, okay, so this 2y is equal to 50 plus x. No, I am just supposing that equation 1, for equation 1 this is when y is a dependent variable, when y is depending on x. For the equation 2 I will consider that x is depending on y. It is an assumption. So from here we get this y is equal to x by 2 plus 25. So the slope of this line is 1 by 2 and we know this denotes the regression coefficient which is byx. Okay, and now let's assume that equation 2 shows the dependence of x on y. So the second equation was 3y minus 2x minus 10 equal to 0. From here we can write that 2x is equal to 3y minus 10, x is equal to 3 by 2y minus 5. So from here we get this bxy is 3 by 2. Okay, now we know this r is equal to I will write it on next page. We know this r is equal to byx sigma y sigma x, and this is also equal to bxy sigma x by sigma y. So when we multiply both these equations, we will get r square is equal to byx into bxy, and r is equal to root over byx into bxy. These are the this is the correlation coefficient. Byx is regression coefficient of y on x, and similarly bxy is regression coefficient of x on y. So we find these byx and xy value. So byx is 1 by 2 and bxy is 3 by 2. R is equal to 1 by 2 into 3 by 2, which is um, approximately equal to 0.866. Okay, so we got this value. I hope you understand the problem. Now, moving to the next question. There are two series of index numbers, P for price index and S for stock of the commodity. Okay, S represents the stock and P represents the price of that stock. Now the mean and standard deviation of P are 108, and similarly mean and standard deviation for S is also given. Now the correlation coefficient between two series is 0.4. With this data, obtain the regression of lines P on S and S on P. So, I am let this price P is denoted by, I am denoted it by X, okay, because like it is easier to understand that. And let stock S is denoted by Y. Now this X bar is 100 and standard deviation of X is 8. This is given in the question. This Y bar is 103 and sigma Y is equal to 4. And this correlation coefficient between these two is also given, which is 0.4. Now we need to find the regression line using this data. We know that when we know the data, then we can easily find the regression line. But here we don't have the data, but we have this average values and this standard deviation. But we also have this correlation coefficient. So from here, we can find the regression coefficient, right? So regression coefficients of x on y, which will be bxy. So this will be nothing but r into sigma y by sigma x, as r is equal to bxy sigma x by sigma y. From here I wrote that bxy is r into sigma y by sigma x. R is given 0.4, sigma y is 4 and sigma x is 8. This value comes out to be 0.2. Now we can easily write this equation, which is y minus y bar, and we know the value of x bar and y bar as it is given in the question. So x minus 100 equal to 0.2 into y minus 103. So this comes out to be x is equal to 0.2y plus 17.6. Am I doing anything wrong? No, I think I'm right. R is equal to bx by sigma x by sigma y by sigma x. Okay. Now, when we find this byx, this will be r into sigma x by sigma y, which will be 0.4 into sigma x is 8. This is 4. This will be 0.8. Now this y minus y bar is equal to 0.8 x minus x bar. Y minus 103 is equal to 0.8 x minus 100. So from here, just a minute. This value will be 79.4. And I will write it on the next page. Point 0.8x plus 23. So in the question we were asked that with these data obtain the regression lines of P on S and S on P. So we found these values. We just denoted this P with X and S with Y. Then we, with this correlation coefficient and this sigma X sigma Y, we found this regression coefficient, and then we use this regression coefficient to find our regression line. Okay. So now moving on to the next question. Just a minute. No, x bar is given in the question, it is 100. This is 100. So here this x bar is 100. Where? Which slide? So this is this equation, this y minus y bar. Look, this is the equation y minus y bar equal to 0.8 into x minus x bar. So I just put these values. Y bar is 103. This is 0.8 x minus 0.8 into x bar, which is 100. So when you move this 103 here, it will come out to be 23. Okay. Now moving to the next question. Now, a statistics instructor at a large Western university would like to examine the relationship between the number of optional homework problems students do during the semester and their final course grade. Now, she randomly selects the 12 students for the study and asks them to keep track of the number of the problems they are solving, and then uh, and at the end each student uh, tally is recorded along with their final grade. Okay, so now there are so this is the table. This is the number of problems students solved. This is the course grade they got. Okay, now in the question we want we want to find the relation between uh, okay. We need to find relation between these two values, these number of problems solved by the students and the course grade. So the first question is, for this setting identify the response variable. Okay, response variable will be the dependent variable. So here the response variable will be course grade. We want to see that how the number of problems people solve influence their course grade. So this response variable is course grade. Okay. Second question is, for the setting identify the predictor variable. So which variable is predicting? Okay, so this the number of problems solved by students is the predictor because it is predicting the course grades. Okay, so this is the predictor variable and this is the response variable. Now we need to find the linear correlation coefficient R for this data. So this is the data. So we know the formula for finding the correlation coefficient. So this time I am using the new formula. So this formula is also derived from the previous formula, which was xi minus x bar into yi minus y bar upon sx xy. Okay, so this is reduced to this formula. Okay, because it is easy to compute, because we have this table, this is the x, this is y. We took their multiplication x into y column by column and then add those values. The last column is showing the summation of uh, all the columns. So this is 873 is summation of this column, 848 is summation of this column, and 62254 is summation of this column. So in this formula, so this is also a formula for finding the correlation coefficient. So this sigma xy is 6 62254. Sigma x is 873. Sigma y is 848. N is equal to 12. And from the data we will find this value of Sx and Sy. So I think you guys can find this Sx and Sy from this data. And on putting all these values in this equation, we will get R around to be 0.885. Okay. And this value is positive value. So there is a positive relation between the number of questions, number of problems students are solving and their course grade. This is showing a positive correlation, which means that this is x, this is y. With x, this y will increase in this linear positive fashion. Okay. When x is increasing, the y will also increase. Next question was classify the direction and strength of correlation. So direction is positive and strength is also, it is 0.885 and correlation coefficient value is between 0 to 1. So it is showing 0.885 is showing a moderate range. When it is close to 1, then it is saying there is a strongly positive correlation, but it is 0.885, then we can say it is a moderate positive correlation. Now we want to find the test hypothesis for a significant linear correlation with alpha equal to 0.05. So for this hypothesis testing, our H naught is, we need to, here the question is test the hypothesis for a significant linear correlation. So H naught will be that there is no significant linear correlation, and H1 will be there is a significant linear correlation. Okay. Alpha is given 0.5, sorry 0.05. Degree of freedom will be n minus 2. N is equal to 12, so degree of freedom will be 10. So I am taking this t test. So t alpha by 2 comma duf is 10, which is t 0.025 comma 10. This value comes out to be 2.228. Oh, sorry. So in this hypothesis testing, we are our can you mute your system? Yeah. Uh, Thank you. So in the null hypothesis, we are taking that there is no significant correlation. There is no significant linear correlation. That's why this correlation coefficient will be 0. The other hypothesis will be that there is some significant correlation. So the alpha is given 0.05. Degree of freedom for this is n minus 2. N is given 12. So degree of freedom will be 10. So this is a equal to and not equal to. So this is a two-tailed test. That's why this value will be we will calculate it for alpha by 2. So this alpha 0.025 comma 10 is 2.228. Okay. Now we will find our test statistics, which will be r upon root over 1 minus r square divided by n minus 2. This is our test statistics. So we found this R is 0.885. So our T will be 0.885 divided by 1 minus 0.885 whole square divided by 10. This value comes out to be 6.01. This T is greater than T alpha by 2 comma DOF, right? Because this value was 2.228 and this is 6.01. So that's why we reject null hypothesis. And what was null hypothesis? That this correlation is 0. So this is not correct. This means that there exists a significant correlation between two values. Okay. So we need to find the test hypothesis for a significant linear correlation. So we found that this null hypothesis, we rejected this null hypothesis which was saying that there is no significant correlation. So this is not correct because we rejected this null hypothesis. That's why there exists a significant correlation between these two values. Moving to the next question. So calculate the Spearman's rank correlation for the following data. So in the previous questions we were using the Pearson's correlation coefficient, and now for this question we are seeing how to calculate the Spearman's rank correlation. Okay. So here also we will make a table. We are given these values. So the 14, 15, 17, 12, 16. Okay, so these are the values given to us. Now in the Spearman's rank, uh, um, formula, we use the rank of the data. Okay, so here we will find the rank for all these values. So the smallest value will be considered as rank 1. So for this column, for the mathematics column, this 9 is the smallest. So this will be ranked 1. This 10 will be ranked as 2. This will be ranked as 11 will be ranked as 3. 12 will be ranked as 4. Then 14. Then 15. Then 16. Then 17. And then 18. Okay, we rank the data. These are the ranks. Similarly, we will give ranks to this column as well. So here this will get rank 1, rank 2, 3, 4, rank 5, rank 6, 7, 8 and 9. Okay, so here the minimum is 2, so we assigned it rank 1. Then the next element was 3, so we assigned rank 2 to it. Then there was a 4, we assigned rank 3. Then to this element we assigned rank 4. Then above 5 there was 7, so we assigned the rank 5, and similarly we assigned rank to all the elements. Now we will find the difference between the rank of the first element. Okay, so the difference in the rank elements is 5 minus 3, which is 2. Then we do it for all the elements. Then 6 minus 6 minus 9 is minus 3. 8 minus 6, 2. 4 minus 8, minus 4. 7 minus 1, 6. 3 minus 4, minus 1. 9 minus 7, 2. 1 minus 2, minus 1. 2 minus 5, minus 3. Then we take square of these values. This will be 4, 9, 4, 16, 36, 1, 4, 1, 9. Now this correlation formula for this Spearman's formula is 1 minus 6 into sigma d square upon nq minus n. This sigma d square will be summation of this column. Okay, it looks like that. So when you compute this will come out to be 84. So now we will, and n is 9. So Rk will be 1 minus 6 into 84 divided by 728 minus 9. This comes out to be 504 divided by, sorry, this is 729. 720. This comes out to be 0.3. So the Spearman's correlation coefficient is 0.3. So it is saying that there is a positive correlation, but the correlation is not very high. It is 0.3. It says that it will be something like this. The slope is 0.3. If the slope was higher, then it would look like this. But it is around 0.3. This means it is somewhat, it will be increasing, but the slope is less. Okay. So this is how you can use the Spearman's correlation coefficient. Moving on the next question. So we are given the five pair of observation, and the following results are obtained. The sigma x is 15, sigma y is 25. This is sigma x square. And this is sigma y square. And all the values are given to us. Okay. This sigma x square, sigma y square, sigma xy. Now we need to find the equation of lines of regression and estimate the value of x on the first line when y is equal to 12 and value of y on the second line if x equal to 8. So with this data we will first find the two regression lines. One regression line is when x is depending on y, and another will be when y is depending on x. And then for the given values of y and x, we need to find the values of x and y. Okay. So this n is equal to 5, sigma x is 15, so x bar is equal to 5. Sigma y is given 25, so y bar is 5. Okay. Now we will find this bxy. This will be n into sigma xy minus sigma x sigma y divided by n sigma y square minus sigma y whole square. N is 5. Sigma xy is given 83. So 5 into 83 minus sigma x into sigma y. Sigma x is 15 and sigma y is 25 divided by n into sigma y square. Sigma y square is 135 minus sigma y whole square, which is 25 whole square. So this value from this will come out to be 0.8. Now we can find the regression line, which will be x minus x bar equal to bxy y minus y bar. X minus 3 equal to 0.8 y minus 5. So on solving we will get that x is equal to 0.8 y minus 1. So we found this regression line when x is depending on y. So now we need to find the value of x when y is equal to 12. So we will put in equation 1. So we get x is equal to 0.8 into 12 minus 1. We will get 8.6. Okay. Now we need to find regression line when y is depending on x. So this byx will be n sigma xy minus sigma x sigma y divided by n summation x square minus summation x whole square. So again we know all these values. Sigma x square is 55. This comes out to be again 0.8. So now we can write this value y minus y bar is equal to 0.8 x minus x bar. Y minus 5.8 x minus 3. Y is equal to 0.8 x plus 2.6. So now in the question we are asked to find the value of y on second line if x is equal to 8. So this is equation 2. So put x equal to 8, we get y equal to 0.8 into 8 plus 2.6, which is equal to 9. Okay. Moving to the next question. So we are given two correlation lines, two regression lines, and we need to find the correlation coefficient. So we have solved this type of question earlier also. Okay. So I will again solve this question. So we are given two lines 3x plus 2y equal to 26. So from here, let's suppose assume this is a regression line for y on x. We can write this 2y equal to 26 minus 3x. Y equal to minus 3 by 2x plus 26 by 2. So this byx is minus 3 by 2. Alright. Similarly, other is 6x plus 3y equal to 31. So assume this regression line is for x depending on y. So we can write 6x equal to minus 3y plus 31, x equal to minus y by 2 plus 31 by 6. So bxy is equal to minus 1 by 2. So we know this r is equal to root over bxy into byx. So this value was minus 1.5 into minus 0.5. So this comes out to be 0.866. Okay. Moving to the next question. So for the given following lines, find the regression coefficient and the coefficient of correlation. So this is similar to the previous question. In the previous question we also found the regression coefficient, which was bxy and byx, and the coefficient of correlation will be root over bxy into byx. So I am not solving this question, but I am putting the answers. So this bxy is 2 by 3, byx comes out to be 1 by 4, and r will be bxy into byx, which came out to be 0.4082. So you can check this on your own. So today we discussed the how to find the correlation coefficient, how to find the regression line, how to find the regression coefficient, and how to test the hypothesis. So I will take little more time to explain how this test hypothesis thing works. Okay. So in the lecture also the sir has taught few questions. I didn't added very much questions based on that, but I will try to explain it with an example. So so I will explain it in somewhat different way. Okay. So first we will talk about this sum of squares total, which is denoted by SST. This SST is given by sigma I equal to 1 to n yi minus y bar whole square. Okay. This is the sum of squares total. Then there is a term sum of squares regression. This is difference between the predicted value and the actual average. So what is the predicted value? What is y bar cap? Oh, sorry. So this is the predicted value. From regression line. This can be denoted by axi plus b. These a and b are the coefficient. A is the slope and b is the intercept. Okay, so this SSR is nothing but summation of axi plus b minus y average of, this is the average of actual data, this is the value of predicted data. Okay, so this sum of square of regression is this thing. Then there is sum of square error. This is yi minus yi cap. This is the actual value, this is the predicted value. So difference and the sum is the error, because this is the error, like we have some actual values and we made a model and we predicted those values. So difference between the predicted value and the actual value is error. Okay, so the sum of squares error is the is denoted by this formula, that first we take the difference between the actual and predicted value, then we take the square, and then we sum it for all the elements. This will be the sum of square errors. So there are three things. First is sum of square total, that is difference between the actual data and the average of the actual data. Second is sum of squares regression, which is difference between the predicted value with the average. And the last is sum of square error, which is difference between the actual data and the predicted data. Okay. So I can explain it with this diagram. So let's suppose this is the regression line. Vx plus b. Okay. So these dots denotes the actual data. This is our regression line. This is our average. This y bar is the average. Okay. Now for this I, we got this is the predicted value, because this is on the regression line. This is the predicted value for this xi, and the actual value is yi. So this difference between the actual value and the predicted value, this is error, sum of square of the error, this value. Okay. The difference between the actual point and the line, difference between the actual point and the point which lies on this line, this denotes the sum of square of errors. The SST was this yi minus this y bar. This is SST. So I am just removing all these values so you can understand this. So you understand that this is the point, this is the actual point, this is the predicted point, and this is the average value. So difference between the actual point and the average is SST. Difference between the actual point and the predicted point is error, and difference between the predicted value and the average is sum of square of regression. Okay. So I hope this is clear. Now let's suppose these values, we take an example, these all the values are given as this. This SST is 13.704, SSR is 10.568, and SSE is 3.136. Okay, just remember these values. So now we will see how we can measure the goodness of fit test. Okay. So first is determining the coefficient, that is there is a coefficient, like is there a, does the two elements has some correlation. If we want to test that, then how do we do that? So first thing is we need to find this coefficient of determination. This is r square. This is nothing but difference between the predicted value divided by actual value. So this r square is nothing but, this is SSR and this is SST, yi minus y bar. So this denotes the coefficient of determination. Or we can write it as 1 minus summation of error upon SST, because this SST is equal to SSR plus SSE. We can write it as this SSR by SST and 1 minus SSE upon SST. Now we will see this F statistics in simple regression. So in this we are testing whether slope of regression model is 0. Okay, we are testing this thing in this F statistics test. So this H naught will be that this B1 is 0 and H1 will be that B1 is not 0. Okay. So for this we will calculate few values. First we will calculate the mean square correlation, mean square regression, which is SSR upon K. K is the number of elements, number of independent element. So this y is equal to ax plus b. So there is only one independent element, right? So for linear, so this is only one independent variable. That's why k is equal to 1. So this MSR is SSR upon k. So in our case, This k is equal to 1, so it is equal to SSR. Now we will find this mean sum of square error. So this will be sum of square error divided by n minus k minus 1. Okay, so whatever will be the value of n, we will put it. K is 1, so this n minus 1 minus 1, which is equal to SSE n minus 2. So this MSR is SSR, which is y predicted value difference with average whole square. MSE is SSE by n minus 2. This is actual value minus predicted value whole square divided by n minus 2. These are these two values. Now we will find our F statistic, which is MSR divided by MSE. This is summation y predicted value of y minus y average value divided by summation actual values minus predicted values whole square divided by n minus 2. Okay. And we are claiming that this MSR upon MSE should follow this F statistics with some alpha and degree of freedom n minus 2. So okay, so we will find this value with for the given alpha and given n. We will found some test statistics, and if this MSR upon MSE is greater than this, we reject null hypothesis. Okay. Then another hypothesis test is for testing regression coefficient. So okay, I didn't cover this in the examples. So regression coefficient. So here we use this T statistics. So here this T statistics value will be B minus upon SB vector. This is the point estimation for slope of regression line. This B1 this is hypothesized slope. We can take this 0, we can take it anything. This is like we are checking whether the slope of this regression line is capital B1. This B cap is the point estimation for the slope of regression line. at this SB vector B cap is standard error of the slope coefficient. So our H naught will be that this B1 is equal to 0. Okay. And null, the alternate hypothesis can be that this is not equal to or except B0. I can write capital B1. This is not equal to B1. H naught can be that this B1 is greater than this capital B1. H1 can be that this B1 is not greater than capital B1. Okay. Or it is less than capital B1. This SB cap is calculated as standard error divided by summation over I xi minus x bar whole square. This is the dependent variable. Okay, this xi is the dependent. This se is the root over mse, where this mse was summation y, actual y values, predicted y value whole square n minus 2. This was the mse. So this SB vector is SE divided by this. SE is root over MSE, where MSE is this thing. So this SB vector is root over summation actual values of y minus predicted value of yi whole square divided by n minus 2. Okay, into this thing summation, or I can okay, this is SB vector. Now if this T statistics is greater than T critical, or if this T statistics less than minus T critical, critical by critical I mean for this given value of alpha, for some given value of alpha. Okay, then reject H naught. So this we have covered in the previous lectures, that when to reject H naught and when to not. Okay. So now I will just give an example, a small example. Let's suppose we have this regression line y equal to 7.112 minus 0.902x. Okay, this is the equation line. Now the null hypothesis is that this b1 is less than 0, and alternate hypothesis is this b1 is greater than 0. Okay, so now we need to calculate this t is nothing but b1 minus b1 divided by SB vector. So b1 is slope of the line is minus 0.902, and we are hypothesized that the slope is comparable to 0 or not. So this capital B1 will be 0. And we found this SB vector, it is SE divided by summation xi minus x bar whole square. And this SE is root over MSE, which is equal to root over SSE upon n minus 2. So let's suppose we are given this SSE value. This is 3.136. So this SE will be root over SSE upon n minus 2. This is 3.136. And this n is equal to 10. This is 8. So we got some value which is 0.6261. Let's suppose this sigma xi minus x bar whole square root is or this is given to be 12.989. SB vector will be SE divided by summation xi minus x bar whole square. SE was 0.6261 divided by root over 12.989. This value comes out to be 0.1737. We find our T statistics, which is B1 minus B1 divided by SB vector. This is minus 0.902 minus 0 divided by 0.1737. This value comes out to be minus 0.193. And we found our T DOF comma alpha, which is DOF is 8 comma 0.05. This value comes out to be 1.860. So this here this alternate hypothesis was that this B1 is greater than equal to 0. So we reject H0 when this T DOF comma alpha is greater than T statistics. So this T DOF is 1.860 and T statistics was minus 5. So actually this is greater than this T statistics. That's why reject H0. So rejecting H0. So what was H0? H0 was that this B1 is less than 0. So this is not true. Okay. So we are rejecting H0. Okay, ma'am, statistical tables will be provided in the line. Yes, they will be provided. Or you can, or the value will be like, I am not aware of like who is making your exam papers, but generally in such papers they will give you the statistical tables, and if they don't give you them, they will put the values for this statistics. So this is all for today's lecture. Okay. Uh, okay, yeah. Yeah, yeah, you can share the screen. Avirish, do you have any question? You raised your hand. Okay. Okay. Oh, oh, oh. Can you? Yeah. Can you show me the question? Okay, suppose a student. Sure. Okay, so what is the problem here? Like, the solution is given, the solution is wrong, or what? Yeah. Okay. You are considering T alpha by 2. Right, 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 right. Hmm. Yeah, yeah, yeah. But now it is small, so you are using this T. Okay, okay. So maybe there is this error because like this question is not made by us. Like we are just uh, like we cannot contact these persons. We don't know who made these questions. So yeah, but you are right. I think like this, as you said that the sample size is small, so you need to use this T statistics rather than Z statistics. So yeah. So you both are facing the same issue because if yes, then so maybe then there is some, maybe the solutions are incorrect. Okay. Hmm. I see. So that will be from the Z distribution, Z test. You checked it? Okay, okay. From to T. Okay. From Z test. Okay. Hmm. So maybe the like you can send them a query, or you can write to NPTEL lectures. Hmm. Okay, so I think they will reply you like after this week or so, maybe. But you are right. Like when the sample size is small, then you need to use this T statistics. Okay. Yeah. Okay.